All right, guys, here we go. We're going to start Unit 3 material with Chapter 12.1, Sampling Techniques and Misuses of Statistics. Our notes that we're going to go through do not talk about the misuse of statistics much. We were going to start the day with a media quiz over those misuses of statistics. Statistics can be very, very valuable when they're used properly. But a lot of the time people misuse them in order to support their own belief or opinion to get you to believe the things that they believe. You need to always examine statistical statements very carefully before accepting them as fact. 3 different ways that statistics can be misused. Sometimes you will see that statisticians use vague or ambiguous words. They give you feeling statements, perhaps. They can also state a claim that encourages an irrelevant conclusion. Facts can be introduced that don't give you a cause for what they're trying to show, but that they look like they ought to support the argument. And finally, you need to beware of misleading charts and graphs. Watch out for axes that have been manipulated so that there's big gaps or they're not regularly spaced in order to show a steep increase or decrease. Okay, those are just some quick ways that we see statistics being misused. Let's go now and start our notes and talk about some sampling techniques. But before we talk about sampling techniques, we're going to define statistics. Statistics is both an art and a science. It is defined as the art and science of gathering, analyzing, and making inferences Inferences are another word for predictions from numerical information. I say statistics is both an art and a science because the science of data analysis gathers the data and calculates according to that data, but there's an art in a way that the ranges can be set, the way the boundaries can be set, and the way the statistics can be presented. That art part is what allows a good statistician to represent the data in a compelling way. As I give these notes, we are in the middle of the coronavirus pandemic, COVID-19, and you see a lot of statistics on the news. You have to be careful about how things are presented and who is doing the presentation. Okay, inferential versus descriptive statistics. These are the 2 main branches of statistics. Inferential statistics are concerned with making predictions. Concerned with making predictions and generalizations. Right now, there are a lot of statistical models out there about the course of this virus. We are talking about flattening the curve and trying to isolate ourselves from each other in order to slow the spread, try to keep the demand on our hospitals down below the threshold where we can handle the cases coming in. That's inferential statistics. Right now, we're seeing estimates anywhere from 2 weeks to 8 months that we would need to stay inside and to shelter in place in order to flatten that curve. Some of the models are going to be much more correct than others. Most of them, I assume, have been created by good statisticians. We work with what we have, and when we make predictions, they're not always going to be accurate. Descriptive statistics, on the other hand, is just interested in collecting, organizing, and describing or analyzing the data. If you are a descriptive statistician, you aren't trying to make predictions. You aren't coming up with models to predict what is going to happen. You're just giving the numbers about what is happening right now. Okay. Anytime you're gathering information, you're gathering that information about a certain population. The population is all items or people of interest. A population for statistical purposes does not have to be people. It could be things that we're interested in. It's just the group that you're studying, whatever that group might be. There are different types of sampling, and we're going to talk about those different types of sampling. We've got 5 main types that we're going to study. The first one is random sampling. If a sample is drawn in such a way that each time an item is selected, each item in the population has an equal chance of being drawn. An example of this is the lottery. Everyone has the same opportunity to win. Consider the election of 1936. This magazine surveyed people to see who they thought would win the presidential election. They sampled 10 million names, which were selected from phone books, car registration forms, and club membership lists. The survey said that Landon was going to win. In fact, some said Landon by a landslide over Roosevelt. What actually happened was that Roosevelt swept the election. Now, the sample size was good. They surveyed 10 million people, but was their sample random? Well, no. Look to see where they got their names. They got names from phone books, car registration forms, and club membership lists. Think country clubs. Now, this was 1936. Not everyone had a phone, not even a car, and certainly not many people had club memberships back that far, but especially in the 30s, because that was when the Depression was hitting in the Dust Bowl. So at that time, those lists only contained the names of the wealthy. And this is happening at a time when the majority of our nation was poverty-stricken. They were trying to find enough to eat. So it was not a random sample. It was a large enough sample, but it was a badly collected sample. All right, the next way to get a sample is systematic sampling. This is when you have a random starting point and then select every nth item. So nth can be, you're going to start with, if you are checking for errors of things coming off a production line, you might start with the 5th thing on the production line, and then you're going to check every 7th item. This is systematic. It is random because it has a random starting point, and you're not checking every one. Third is cluster sampling. Cluster sampling is when you sample random groups of units, or also it can be called an area sample. To come up with a cluster sample, you want to think about dividing an area into sections and then randomly picking the sections that you are going to sample. Either each member of the selected cluster is included, or only a random sample of the members of that cluster is included. For example, if you were going to take a poll, maybe you're going to ask who people were going to vote for mayor, or maybe you're trying to find out if the city would support opening a new dog park. But if you're going to take that poll, you don't have enough people or enough time to go out and talk to every individual, not even every household. So you might randomly select city blocks. The city blocks would be the geographic areas, and you might look at a map and pick 5 at random, and then send people out to knock on doors on those 5 different city blocks. That's an example of cluster sampling or area sampling. Okay, our 4th method of sampling is stratified sampling. This is the process of dividing a population into parts, and we're going to call those parts strata. Stratified sampling involves dividing the population by characteristics. And those are called stratifying factors. Now, a stratifying factor could be gender, race, religion, income. It might be whether they live in a rural, urban, or suburban area. Anything that identifies a difference within the overall population could be a strata. When a population has varied characteristics, it can be helpful to separate them into those classes with similar characteristics and then take a random sample within each stratum or each class. This is why whenever you fill out forms, they ask you those identifying questions to help so that when they pull out their statistics, they can divide you into different classes to compare. All right, number 5, convenient sampling. Now this is the easiest and it's also the least helpful. Convenient sampling is when you use data that's easily or readily obtained, and it can be really biased because if you're doing convenient sampling, you're usually just sampling one group. You are asking your Facebook friends, so that's a convenient sample. It's the group of people who you are friends with and who think like you. You might stand outside a grocery store and ask people as they come out. Well, that is convenient because it's a certain one time of day and it's one physical location. All right, the rest of this page is practice. It says to identify the type of sampling that was used to obtain each sample. Now, I'm not going to read these because you can read them. I want you to pause the video, work through these, write down your guess, which type of sampling was used, and then come back and see if you were right. All right, on A, classified according to age. That's a class. And within that, you're going to take a random sample for each age group, stratified. Every 10th Samsung television coming off the assembly line, so that's every nth. That's systematic. State is divided into counties, that's geographical regions, and then a random sample of 12 counties is selected. That is cluster or area sampling. On D, the Food and Drug Administration, this one is also cluster sampling. E, door prize given away, tickets in a bin mixed up, kind of like bingo. This one is random. F is another example of stratified sampling because we identify different classes or groups by the different types of businesses. First 30 people leaving the theater is definitely convenience sampling. 20th person in line is going to be systematic. Bingo is an example of random sampling. And then that student senate question, that's convenience because it's just people leaving the library.